All right, region number 3. So these are the region of sp2 carbon, but just regular sp2. Okay, and it's a by the way, so sp2 carbon are more deshielded than sp3 carbon, and because of the orbital effect, right? So all sp2 carbon that are up here are really deshielded from 100 or over. Okay, sp3 is 100 or below. Anyway, all right. So we got a carbon on aromatic compounds like benzene or the carbon of an alkene. The range is anywhere from 100 to 150, depends on the compound, the molecules, but I'll give you like a range, and in the middle of the range about 120, 125, around that. All right, let's do this. So I want you to match this carbon A through E to the spectrum. Okay, let's count real quick. So we have 1 2 3 4 5 signal. 1 2 3 4 5, exactly five signal. Ignore the solvent down here. All right, I'm going to draw the line real quick, so just make just like for me it's easy to look at. All right, so obviously the regular carbon A, right, is going to be that really upfield, really shielded, right? That's A. The rest going to be, all right, how do you put B, C, D, and E on here? Okay, all right, let's do this. B is just a quaternary carbon. I mean, it's a quaternary carbon, right? C, D, and E are CH. If you still remember that trend, a quaternary carbon is more deshielded than the rest. Okay, so I'm going to guess that carbon B is right there, a quaternary carbon, more deshielded. All right, the rest gonna be C, D, and E. To be honest, they are all CH, right? So chemical ship is really close. I can't tell now where they are. I mean, that's just right here. So, okay. All right, that's oh, by the way, so when I teach this, some students are really serious about like picking carbon, pick and choose carbon and try to match our spectrum. Most of the time it's not necessary that you can identify or match the carbon to the spectrum, to the signal. Okay, not always. We have some other technique to help you. I like right here. So as long as you know these are aromatic region, you're good. Okay, you don't actually need to know which one is C, D, and E. I mean, they're really close. It's around right here. At least we know that these exist in the molecules, and there are 1 2 3 4. There are 4 signal on aromatic this aromatic compound. So 1 2 3 and 4, and you can kind of be able to come up with the benzene structure, something like that. We'll get to the detail later how to come up with the structure. Okay. All right. One more time. So again, same drill. Pause the video. Try on your own. No, I don't just like try to go with me. I want you to think, so you have to be able to do this on your own. All right, let's do what we get. I'm going to draw the line first at 50 ppm and then at 100 ppm. You get region 1, 2, and 3 right here. Okay. All right, let's do this. So I obviously the sp2 carbon region is right here. So these two are going to be either A or B. Okay. So what's the tiebreaker? Well, B is a quaternary carbon. A is just a regular CH2, and you remember the trend, so B is going to be right there, more deshielded, and then A is right there. Here we go. Okay. All right, next one. What can we do here? We have a regular carbons, CH3, oh, C and D are alpha carbon, but D is a CH. C and C is CH3, just like E. Okay, so I'm going to guess that D and E gonna be D is gonna be, I'm gonna put D right there, and only because okay, C and D are alpha carbon, gonna be more deshielded than E. These two are E. Now we have 2 E's. Okay, and D is a CH, which should be more deshielded than CH3, so I'm putting D right here and C up there, and the last one E, the most shielded upfield. There we go. All right, let's move on to the last region number 4.